Okay, then let's continue with the next presentation. We move from a module supplier, from one of the world's leading module suppliers, to a world-leading backsheet supplier and producer. And we have with us Stephen Gong, who is a senior product manager at Cybrid. Stephen has a double bachelor degree for chemical engineering and material science. He's responsible for the Cybrid backsheet and encapsulation material application supporting, and he has more than a decade of experience in developing and working in reliability of different backsheets. Stephen will talk to us today and about the latest updates from Cybrid. Stephen, the floor is yours.
Yeah. So can you see my screen?
Yeah, you might want to go into presentation mode.
Okay. Yeah, the topic for me today is the leading total packaging solution for enhancing module reliability. My name is Stefan. I want to show you something new about research from Cybrid about the encapsulation technologies.
Stephen, can you move into presentation mode?
Yes, you don't see it, or?
Yeah, no, we see, but we see still all the PowerPoint.
Okay, okay, you need it.
Yeah, okay.
Okay, perfect. Okay,
super.
Yeah, the major topic for me today is the PVDF revolution from Cybrid roadmap. The second is the encapsulant film revolution, because Cybrid is not only a backsheet maker, but we are also producing a lot of EVA, EPE, or POE, this kind of film for module making. The third solution is the transparent backsheet solution from Cybrid, which is now very hot topic for bifacial modules. The last one is the high reflectivity version black backsheet, which is mainly made for rooftop application. Yeah, the first one is about the PVDF revolution. Yeah, I see the first presentation done. Did they find some cracking on the PVDF backsheet? Yeah, you know, there are many kinds of PVDF on the market, and also Cybrid is the biggest PVDF manufacturer in China. So you know that based on the module development, major is the 2 bus bar to 9 bus bar, or even now is round ribbon or triangle ribbons. This has a leading the change of PVDF films. So you know that different kinds of PVDF sometimes cannot pass some thermal stressing tests like TC 200, 400, or 600, or using different ribbons, because the ribbon concentration, the force concentration on the ribbon is a major influence on the PVDF film. So now it is already the newest PVDF. Like in China, we call Gen 3 type, that can be used for triangle or round ribbons for MBB cells. But this can easily pass the TC 600 for on module level. Yeah, the next slide is for the encapsulant revolution. You know that the encapsulant is now not only EVA, because bifacial cells, and there are also different kind of like HJT, TopCon, yeah, different single, yeah, glass backsheet or glass modules, mainly for PID or reliability reasons. People choosing a lot of kinds of encapsulant for the modules. Now we can see the EVA is getting using more white EVA is used for the modules because the higher power output. Also, for the glass modules, people like EVA and EPE for the cost reason. They want to replace the PoE plus PoE. For sure, we are also developed something new for HJT cells that is a little bit of different from the traditional modules. They need a higher bonding strength with the cells and also lower acid content. Yeah, the next slide is about the transparent backsheet. The first generation was the total clear backsheet without any grid or pattern on the surface. The second generation is the white pattern on the inner side of the backsheet. This is mainly for bifacial and glass backsheet solution, because this solution can make the module even not heavy as a glass backsheet. The last solution from Cybrid is the black grid transparent backsheet. This is made for, the front should be black. Then use this kind of backsheet can for bifacial cells. Yeah, I want to stress one thing. For the transparent backsheet, people always talking about maybe damp heat, UV. Yeah, people do a lot of tests, but they don't care about the vibration property of the transparent backsheet, because many dust in the air or from the wind can also have a damage on the backsheet side. So we did some tests, like 14 cent test. This is from the device to drop on the surface of the backsheet, then causing the transmission decrease. Yeah, we can see different backsheet shows different properties after 60 liters sand vibration test. Yeah, we can make a good backsheet that is can even or 20 liters, a little bit of very small change. Another test is the sand blast. This is sand blowing concentration about 10 grams per square meter, and also with the temperature of 60 degrees at the room temperature. This is a test after 24 hours. We see different backsheet can show transmission, losing the transmission even more than 6.31%. While the Cybrid backsheet is very minor change on the transmission rate. The other test is the sequential test. Why we do this? Because this, like damp heat or HF or TC, the single test, you don't see much failure in future, especially you put modules on the outside. Because the real condition is too many combined condition was damaging the backsheet. So I did one test that is interesting for damp heat, UV, TC, UV. Yeah, this kind of sequential. We see some transparent backsheet. They are quite how to say, fail after UV 60. At this step. So but if you only do the single test, you don't see these failures. So I think for this new backsheet evaluation from the module makers or for your reliability study, you can try to refer to some sequential tests to see if this kind of failures happens or not. The next topic is the black backsheet with higher reflection, and also we had developed one a fluoro-free backsheet solution for the popular rooftop solution. Yeah, actually, normally the backsheet, on the roof, the people like double black or single black, means the cell side is total, it's total black. But you know, the black backsheet causing a lot of power, power not higher as the white backsheet as initial. So 5 to 10 watts less than the standard modules. So we did one solution that it was the black grid on the white backsheet inside. So this solution was initially done by Cybrid 2 years ago. We are selling to CSI, Trina, also some other module makers. They use this kind of backsheet for bifacial cells because some infrared light can go through the cells and then reflected by the white part. Then also can increase the power output. Yeah, this is the standard black grid. Then we improve this version to higher reflective additives with the black version. You see the curve, the standard black is nothing, there's no reflection at a total wavelength, while the higher reflective backsheet, we can see the reflection is started from 750 microns to 1020, 200 microns. That this is can contribute to the module power with these figures. I can make explanation. You see the black higher reflective version, we do a 320 watt modules. There is a power gain about 7 watt more or less. With the standard grid, black grid backsheet, we got 3 watt, almost 3 watt. Then the standard black is we got 2.2 watt because this is our single side cells. With the standard black backsheet, there is nothing, no power increase on the module level. People may think that the higher reflective reflection version black is stable or not. So we did a pressure cooker and also the baking test at 170 degrees after 48 hours. Also we did that to sonar. Then we measured the reflectivity curve like this. You see, it's not too much drop on the reflectivity of the backsheet. Then we also do the color difference check through these 3 aging tests for LAB, especially for L, because L it means black and white. Is quite stable for the dubbing modules. Also for the FTIR, we compare the 0 hour and different tests after baking or even 10 feet. The major boundings were not decreasing or disappear. So it means the components is a stable performance. I show one picture that is a pressure cooker test after 48 hours. The left part is we laminate with POE, and the right side we laminate with EVA. It means that using EVA, you get, let's say, the color is changing, there's a bit of gray. While you're using POE, the color is quite stable. And this is also preferred by our customers. The next topic is about fluoro-free backsheet. You know that for the REACH regulations, the electronics, also including PV, is not preferred for PFOs. This is limited on backsheet. Also, for ground installations and the rooftop installations, yeah, the fire accident happens for PV modules is quite terrible. We introduced a fluoro-free backsheet because this, you know that yeah, fluoro backsheet is a problem with burning and creating a highly toxic gas like HF. This can seriously pollute the air, and also the firefighters were not able to put the fire in time because they need to finish to wait the fire totally finished, then they can go to spray the water or the extinguishers. Especially for the rooftop, there are some requests for the backsheet. Yeah, if you for the fluoro-free backsheet, we also requested for more than 150 and 200 kilowatt hours UV from both sides, because the rooftop application is not as severe as on the installations like Gobi Desert. The second is the heat resistance, because the rooftop modules are always working higher temperature more than ground installations. So we recommend the backsheet has higher ITI or TI. Yeah, also for humidity and fire protection and the recyclability, it's better to choose a fluoro-free backsheet for the residential or BIPV or rooftop modules. Yeah, this is our design for this kind of a fluoro-free backsheet. It is made by 50 micron UV resistant and hydrolysis resistant PET. Also, the inner side is 250 micron PET. Then it is a special coating that is without fluorine resins. Yeah, this is also chosen by a lot of Chinese big module players like Trina. They use this kind of backsheet for the rooftop modules. Yeah, we also supply to the customers to solution. If you use a conventional white backsheet, you can use white EVA and transparent EVA to package. If you use black pattern backsheet, you can use 2 EVA, but the bottom type is UV cut EVA. For high reflectivity version, we also suggest to use this type, or you can use the POE on the bottom. Yeah, also I want to introduce some encapsulant solution from Cybrid. As we can see, EVA, POE, or co-extrude the EPE structures have different properties on this radar chart. Due to these different performance, I have made one chart for the market share recently from the market, that is for the clear EVA or the white EVA or co-extrude EVA, different shares. That is showing the co-extrude EVA now type is more popular now for the bifacial glass gas modules. To balance the EVA to POE and also the co-extrude EPE, we had also developed new products to for the market to choose. First of all, let's see the PID performances with different kind of combinations. You can see for P-type PERC bifacial cells, with EVA plus EVA or EVA plus EPE, EVA plus POE or EPE plus EPE. And the last one is POE. For sure, the POE is the best solution for PID resistant for glass modules, but the cost is is quite unacceptable. For the rear side of the modules, yeah, if you use EVA or different kind of setup, also the PoE is the best. So from this test, we had concluded to the summary. Yeah, the best one is PoE to PoE, then EPE plus EPE, then EVA plus PoE. Then EVA plus PoE is similar with EVA plus EPE. The worst one is EVA to EVA. That's why nobody use EVA plus EVA for bifacial glass modules. In order to solve another issue in this PV industry, yeah, the white EVA, we also had improved the performance, because the previous one was single layer white. Then we developed co-extrude AB structure, means clear and white combination. Yeah, also we can make clear white clear solution. That is because the MBB cells with round ribbons is a problem of bad filling at this position. If you use the co-extrude AB structure or ABA structure, this part can be filled perfectly. You can reduce the micro cracks rate of the big modules. We did one test with the co-extrude white EVA power comparison. It is about 4.3 watt increase compared to clear EVA. Also, we compared the generation 1 and generation 2 EVA, white EVA. Micro crack rate can be reduced around 70%. This can solve the wafer is getting thinner, the cells getting bigger. Also, the ribbon bending issue can be solved through this technology. Here I gave you a summary for the general development of backsheet and Fluoro-free PVDF and the encapsulant film, as showing a trend of improving performance and the market trend. For bifacial modules using transparent backsheet, I suggest better to consider the abrasion property and the sequential test to know how it works. Then the high reflection backsheet, black backsheet has around 2.15% power gain, and the aging test shows very stable performance. Now this technology has been used for variation applications such as pattern backsheet or non-fluoro based rooftop type backsheet. Then the encapsulation has developing into co-extrusion type EPE or generation 2 white EVA for PID and micro cracking issues for big cells like M12. Yes, thank you. I think I finished this presentation. If you have some question, please talk to me.
Thanks, Stephen. Very nice, very insightful. So maybe just one question from me. So I think that was interesting that you also now spent really or focused in some part of your presentation on fluoro-free backsheets. How big is the share of those products, and what do you think actually? How big will that be? Because you already mentioned that Trina, for example, is using some of this for its rooftop modules.
Yeah, fluoro-free backsheet, it is not a new thing. It is preferred from European customers and also Japanese customers. You know that fluoro-free backsheet, the major issue is the fluoro or not. But this is, if you don't contain the fluoro resins inside. The best part is even the module is start burning, doesn't create any HF. This is toxic gases can damage the people, is harmful for the people and also harmful for the environment. So that's why big module players like Trinidad, Hanwha, and also Japanese customers, they prefer this one, and also this is preferred by end users. They don't want the modules contains the resins on the modules.
Okay. But so you see that there's a share of non-fluoro polymer is actually increasing.
Yes, because Cybrid before we don't produce any non-fluoro product, but now we produce more than 2 million square meter per month for this kind of backsheet. So I think is increasing demand from our customers, also the global market.
Okay, super.
Yeah.
Okay, I think what would be nice is there are several questions in the chat. If you still have time to answer them, that would be very nice in the chat, actually in written form.
Yeah, okay, no problem.
Yeah, that's super nice. Okay, Stephen, thanks so much for this very nice and insightful presentation. Okay.